You hear all the time about these incredible AI models that can do amazing things. But have you ever stopped to wonder how they actually get from a developer's laptop into the apps that we use every single day? Well, it's a whole journey, taking a brilliant piece of code and turning it into a tool with real-world impact. And today, we're going to break down exactly how that happens. So let's say you're a developer. You've just spent months, maybe even years, training this incredible AI model. It's a masterpiece. It can spot diseases in medical scans, translate languages instantly, you name it. The hard part's over, right? Well, not quite. See, building the model, that's just step one. The real challenge is just getting started. And that brings us to what's known in the industry as AI's deployment dilemma. Here's a way to think about it. Imagine you're a world-class chef, and you've just created a revolutionary new recipe. But you only have a tiny kitchen in your apartment. How in the world are you going to cook that dish for thousands of hungry customers all at once, perfectly every single time? That right there, that's the unseen challenge of AI. Now, this challenge isn't just one big problem. It's really 5 different hurdles you have to clear. First up, you've got scalability. How do you handle your app going viral, jumping from 10 users to 10 million without the whole thing just falling over? Then there's performance. People want answers now. They won't wait 5 seconds for a prediction. That means you need super low latency and high throughput. Next, resource use. The GPUs that power this stuff are seriously expensive, so you absolutely cannot afford to let them sit idle. Every single cycle counts. And what about model versioning? When you create an even better version of your model, you need to be able to swap it in seamlessly with zero downtime. And finally, framework diversity. Your data scientists are using all sorts of tools, TensorFlow, PyTorch, you name it. How do you get all those different models to work together in one system? It's a lot to juggle. So with all those complex problems, what's the answer? Well, this is where NVIDIA's Triton Inference Server comes into play. If your AI model is that perfect recipe, then you can think of Triton as the giant, state-of-the-art industrial kitchen that's been custom-built to solve every single one of those hurdles and tame all that complexity. So what is Triton really? At its core, it's an open-source inference serving software. Open source is key. It means anyone can use it. Inference serving is just the fancy term for actually using a trained model to make predictions on new, unseen data. But honestly, the most important word on this slide is standardizes. It takes what could be a totally chaotic, messy process and brings it all together under one unified, powerful, and organized system. And this is where you can really see the magic of Triton, because it has a specific feature designed to crush each of those challenges we talked about. Remember the problem with speed and latency? Triton solves that with something called dynamic batching. It's super clever. It actually groups incoming requests together on the fly to process them all at once. It's kind of like turning a long, slow, single-file line into a super fast express checkout for a whole bunch of shoppers. That mess of different AI frameworks? No big deal. Triton has multi-framework support baked right in. Worried about wasting expensive GPU time? It's got you covered with concurrent model execution, which lets you run several different models on the same GPU at the same time. That's a huge game changer for efficiency. And of course, it handles model updates without a hiccup and scales up or down with traffic automatically. It's a perfect solution for each problem. Okay, so the theory is cool, but what does this actually look like in practice? How does a model go from just being code on a computer to answering a real request from an app? Let's do a quick, high-level walkthrough of that whole process. Really, you can boil it all down to about 5 main steps. First, you set up the environment using a tool called Docker. This is like getting our industrial kitchen built, laying the foundation, getting the plumbing and electricity all set up so it's standardized and ready. Second, you prepare the model. This just means organizing it in a specific folder structure that Triton expects, like a chef putting all their ingredients on clearly labeled shelves. Third, you hit the Go button and launch the server. The kitchen is now officially open for business. Fourth, a client application, like your phone's photo app, sends some new data, like a picture, and asks, hey, what's in this photo? And finally, step 5, the server sends back the answer. And that answer, that result, can be as simple and as clear as this. Prediction, leopard. You see, all of that incredible, complex infrastructure, all that careful planning and setup, it all comes down to this one simple moment, delivering a single, accurate, and near instantaneous answer. It's that perfect aha moment where all the behind-the-scenes engineering delivers something tangible and useful. But it's not just about getting an answer. It's about getting a fast and efficient one.
Triton also ships with these amazing built-in tools, like its performance analyzer. You can think of this as a diagnostic toolkit for our high-tech kitchen. It lets developers measure everything, latency, throughput, you name it, and fine-tune their entire setup to make sure it's running at absolute peak performance.
All right, let's zoom out for a second. All this technical detail is great, but why does it really matter? Well, because solving this deployment bottleneck isn't just about making life easier for developers. It's about unlocking the entire next wave of AI innovation for all of us. When you get models serving right, the impact is massive, and it really comes in three flavors. First, you dramatically lower your operational costs because you're using that expensive hardware so much more efficiently. Second, applications get faster and more responsive, which is just a better experience for everyone using them. And third, and this is the big one, you seriously speed up the path to innovation. When your smartest people can stop worrying about infrastructure problems, they can focus all their brainpower on building the next world-changing AI solution. So if there's one thing to take away from all this, it's that Triton and tools like it serve as the absolutely essential bridge connecting the brilliant world of AI research and development to the real-world products and services we all rely on. It's the critical piece of the puzzle that lets amazing ideas actually make it out of the lab and into our lives. And that all brings us to one last, really exciting question. You know, for a long time, the biggest hurdle in AI wasn't creating a great model. It was actually deploying it. But now, with powerful standard tools like Triton tearing down that barrier, the whole game is changing. The question is no longer if we can get these amazing models into the real world. The question now is, what will we build next? With that bottleneck gone, what does the future of AI actually look like? That's the exciting new frontier that this kind of technology is helping to unlock.